So if I start at 0 radians right here, my cosine is the x value, which was an x value of 1. So I got 0.01. Rotating around, when I get to pi halves, my cosine, again, the x value is 0. So pi halves 0. When I rotate around to pi radians, again, my cosine is the x value -1 in this case. At 3 pi halves, I get the x value again, 0. And then at 2 pi, a full circle, we got back to this x value again of 1. Okay, so let's see if we can plot those. I went around the unit circle. I went around the same circle. I just was looking at the x's, the cosines. And I'm going to plot those on this graph. So again, my x values are some kind of angle in radians. So I was talking, this is like 0 radians, and then the cosine was 1 at 0 radians. At pi halves radians, my cosine, or the x value on my unit circle, was a 0. So there's my pi halves 0. At pi, this was the point pi -1. 3 pi halves, again, the cosine at 3 pi halves is 0. So we got the point 3 pi halves 0. And at 2 pi, full circle got me back to where I started, 0, 1. That's what happened up here again. At 0 radians and 2 pi radians, I actually went back to 0 on my sine function, cosine function. I started at a cosine value of 1. I ended up the end of that cycle, y value of 1. Okay, so yet again, the bolded part here, that was one cycle. That was me wrapping around the unit circle once. But really, I can go around that unit circle again and again and again. So this would just repeat that same little cycle. There would be like if I went around twice, there we go. If I went around again, so 3 times. I've gone around the circle 3 times. In fact, I could go in the negative direction. Like if I went clockwise on my unit circle, I would hit the same points. So those would be like my negative x values would be my negative angles. All right. What kind of questions do we have? Either on the sine or cosine. Anything? No questions. These are the parent functions. And then we should be able to do all kinds of transformations off of those parent functions. Okay. So on sine and cosine functions, let's look at the 5 key points that we were talking. These are pretty much the 5 points that we looked at on the parent function, right? So I want to look at, how do I, like my maximum and minimum. Wasn't that maximum 0, 1? And this minimum was like pi -1. It was kind of bouncing between those guys. Okay, so max and min, let's find those points. Oops. Sorry, give me a sec here. Come on. Okay. So my max, I want to look at the max. I want to look at the minimum, like the highest and lowest points that it's bouncing between. Also, 2 of these points that I had, they were my x-intercepts. Let's check out the intercepts. And then, in fact, I think I had 2 x-intercepts. And let's check out the y-intercept. The y-intercept in this case was actually the same as one of my maxes, so that is possible. I could also have an x-intercept that could be the same as like a max or min, but I'm still going to check those out. All right, so let's do this in 2 pieces. I put the sine in blue and I did the cosine in green. So my sine, I'm going to find those 5 key features on my sine. So it looks like my maximum here is at the point pi halves 1. Sine of x, I'm going to call it y equals sine of x. All right, so max is at pi halves 1. My minimum, I only had one of those guys. The minimum was 3 pi halves negative 1. All right, so here's those xy points. Let's see, let's check out my x-intercepts here. I think I had, I had 1, 2, 3 x-intercepts. I got 0, 0, pi halves, and 2 pi halves. So I'm just gonna put intercepts in general. Because 0, 0, 0, 0 counts as an x-intercept and a y-intercept. It's kind of these guys put together. So I'm just gonna say my intercepts in general were 0, 0, there was a pi 0, and a 2 pi 0. Okay, so for sine, here are kind of my 5 key points that I would need to graph it. Cosine has 5 key points as well. So my cosine has 2 maximums, actually. It's got the maximum at 0, 1. Oops, and this is supposed to be 2 pi 1. 0, 1, and 2 pi 1. All right, so I had 2 maxes. The min, let's see. I'm looking at just this one cycle right here. And just that one cycle, I had a single minimum right there. That was at pi negative 1. All right, and then let's look at some intercepts. I had 2 x-intercepts right there. Pi halves 0 and 3 pi halves 0. This one was a y-intercept, so I actually already had it labeled in the maximum section, but it also was a y-intercept. So if you want to make yourself a note about that, it's a maximum and a y-intercept. Let's look at that visually. That was this guy right here. It's kind of a high point there, and then it hit the y-axis. Okay, but I did find like the same 5 pieces of information. I got like 5 key points that I would need to graph one cycle. Okay, any questions on these points before we move on? Thanks, Audrey. Thanks, Marcus. Thanks, Nicole. You guys, honestly, we're okay with these? You guys in the classroom, how are we doing? Thumbs up, okay. All right, well then I'm going to move on to number 3 then. Sketch the graph of y equals 2 sine of x on the interval negative pi to 4 pi. Okay, a couple things here. This is not just sine x, this is a 2 sine of x. It is like a vertical stretch by 2. It's one of our transformations. So it's going to be like they take our sine graph up here. It's like they take all these top points, you know, they're going to stretch it out. They're going to like double those. And the bottom ones, they're going to stretch it out. All right. We'll figure out what the final graph looks like. But I'm supposed to go from negative pi to 4 pi. Up here, we were counting, let's see here. We were counting by pi halves. Here's like my negative pi. Here's like my 2 pi. I haven't quite gone up to 4 pi over here though. So we're gonna have to adjust this. Okay. Yeah, Jack, you're basically multiplying the y values by 2. That whole vertical stretch by 2. You're gonna multiply all your y values by 2. All right, so let's label our x-axis here. They were counting by, up on this one, they were counting by pi halves. If I count by pi halves here, I'm going to go with a negative pi halves, a negative pi. All right, which is good. I got the left side. It's supposed to go negative pi up to 4 pi. Let's see the right side here. I've got a positive pi halves, positive pi, and I got 3 pi halves, 2 pi. Are you guys okay to count by halves? By pi halves? 1 half and then 1, and then 3 halves and then 2. 5 pi halves, and then 3 pi. 7 pi halves, and then 4 pi. Okay, so I was supposed to go up to a maximum of 4 pi. So we're kind of graphing within these guys here. Let's get some key points here. Key points. So very similar. I'm going to look at the parent function here. Very similar to the parent function, but like I said, I'm stretching it by 2. So like this y value of 0 multiplied by 2, still 0. That's going to stay there. This y value of 1 multiplied by 2, 1 times 2 is 2. So my max is going to go up to 2. Again, this y value, 0 times 2, still 0. So I'm still going to hit that point. This y value is a negative 1. Negative 1 times 2 is a negative 2. So that's going to go down here to a negative 2. And again, the y value of 0 times 2 is still 0. So it's going to look something like this. Okay. So I'm looking at some key points. It still hits 0, 0. These zeros are still going to be there. 0, 0, pi 0, 2 pi 0. Those are still there. All right, so I'm going to plot those. All right, what about my maxes and mins? I think those guys are the ones that adjusted. I'm going to have to make this one go up to the pi halves 2 instead of pi halves 1. There's my max. So that went up to the 2. My min at 3 pi halves, my min used to be a negative 1. That got stretched down to 3 pi halves negative 2. So that's going down here. Okay. Oops. Down there. Okay. All right, so there's like one of the cycles, but I need to make it go all the way from negative pi to 4 pi. So let's kind of keep this pattern going. From 0 up to 2, down to 0 to negative 2. 0 up to 2, down to 0, and negative 2, back up to 0. So I'm going to do basically this same cycle just one more time. Okay. And then I got to do over to the negative pi. I need some negative x values here. So I'm going to keep this pattern going. Let's start reaching out here. Kaylee, what would you put in, like at negative pi halves, what y value do you think it'll hit?
Negative 2.
Negative 2, down here? Yeah, totally. which once it gets to its negative, it like bounces back up, right? So that's going to go from the -2 and it's going to start bouncing back up. So then, let's see, Ethan, where does it stop at negative pi?
Negative pi, 0.
0, hits 0 at negative pi. Okay, so it goes kind of like this. Same pattern over and over and over again. This was one period, was from 0 to 2 pi. It was like one of those cycles. And then we just kind of repeat it over and over and over again. Okay, so do I have any questions? No questions? All right, so then I'm gonna have you guys try your cosine. Again, you've got a 2 in front of your cosine. So very similar to this 2 in front of my sine. You have a vertical stretch by 2, but you are stretching cosine by 2. So I'm gonna give you guys a sec. Let's see if you guys can put your graph together. Yeah, get some of those key points and then kind of repeat the cycle. I'll just start calling next person, next person, next person, get more and more points to connect. Okay, good question, Nicole. No, we are multiplying the y values. Because that 2 is on the outside of your cosine, you are still just going to multiply all the y values of this cosine parent function. All those y values are multiplied by 2. Yeah. All right, so while you guys are getting those points, I'm going to label my x axis the same way I did before.
Yeah.
Haven't drawn it yet, though.
Well,
Yeah, we're gonna draw it. All right, so for some key points here, so I'm gonna have, let's see, Audrey and Jackson and Shara, Sky. Sorry, I wrote this down. And then let's have Ashley give me my 5 key points here. So Audrey, pick one of those key points. You guys just type it in.
Oh, okay.
Oh, either way.
0, 2 was one of the points I got.
All right, 0, 2. All right, and then Jackson, what'd you get? Shara got a 0, -2. Wait, 0, 2 or 0, -2? Because I can't have both. That would be a 0, 2. This would be a 0, -2. Yeah, I think I got the 0, +2. This was a +2 in front here. It would have had to be a -2 in front here to get the point 0, -2. Jackson, you got pi 0. So Jackson, let's look at this one real quick. At pi on my regular cosine function, pi hit the minimum, -1, which I'm kind of taking this minimum and stretching it down to a -2. But I can multiply that by 2. This 0 multiplied by 2 stayed at 0, but -1 multiplied by 2 goes to a -2. So I think, Jackson, I think you were looking at this point as opposed to the one at pi. Check out the one at pi. All right, so at pi, what should the y value be if my x value is pi? Yeah, nice. Pi and then -2 for the y value because you stretched it. Good. So I'm going to adjust that 0 to a -2. All right, and Shara, we kind of have the 0 taken care of. We have the -2 taken care of. Shara, what about the, let's have you try the pi halves. Looking at my parent function, here's my pi halves. What happens if I do this y value times 2, Shara? And then Sky, let's have you get your 3 pi halves points. Yeah, Shire, it stays the same. 0 times 2, still 0. So I'm actually going to have the point pi halves 0 on here as well. So Sky, we were going to have you do the 3 pi halves, right? So Sky, let me know what you got for that. And then Ashley, what about the 2 pi for you? What's your y value when your x value is 2 pi? Two as well, nice. So Sky, are you there, hon? Let's start plotting these. Pi -2, pi halves 0, 2 pi is up to a 2. All right, I'm not hearing back from Sky. Do you guys in the classroom, do you guys have your y value for the 3 pi halves? What is it? 0 as well? 3 pi halves 0, which I guess that kind of makes sense because if I keep this going, right, I kind of know I would have to bounce back up and hit 0 at some point to get up to that positive. So yeah, my 3 pi halves here does hit the 0. Very nice. It looks like it's a V. I know I plotted the points. It looks like a V, but beware, this is a curve. This is like one of those cycles here. So kind of make it into a curve. Okay, so this is one period right here, one cycle. And then we gotta basically repeat that same cycle. Okay, so then it's going to go from the 2 down to the 0, -2, up to 0, and +2 again. So that same cycle. Again, I'm going to make it a curve. All right, now they said I was supposed to go from -π² to 9/2. My -π² is over here. I haven't quite hit that one yet. So let's see here, Francisco, what should my y value be at an x value of -π²?
I don't really know.
Okay, so if I keep this pattern going, like see how this is like its maximum? Let's look at the other maximum here. This other maximum to the left hits down to this y value. So if I keep that pattern going, oops,
Would it be
then this 0, nice. Yeah, totally. Goes down to 0. All right. There we go. All right, so it said I had to go from -π², okay, from there to 9π², which, let's see, 9/2, it's like 4.5. 9π² is a little past my 4π. So I got to go over to here. I still need an extra point over here. All right, so Kislev, what should my point at the 9π² be?
0.
0 also, nice. It kind of goes to its maximum, turns around and goes down to 0. There we go. Kind of kept the pattern going. Any questions? So you guys can graph these. If I didn't ask you 2 cosine, if I asked you for like a cosine of x plus 3 or something like that, could you do this, shift the whole graph up 3 instead of stretch it? Can you shift the whole graph up at 3? Kind of do all your transformations on that parent function. Okay. Speaking of transformations, let's look at this. They've applied this for both sine and cosine. They've got like an ABCD going on here. Beware, a lot of people write it like this. A lot of people put their sine function first and then they put a plus D at the end. This one put a D at the beginning. It's the same thing, ladies and gents. You can add in whatever order you want. So hopefully, regardless of how they write it, we can kind of recognize they're talking about the same thing. Same for the cosine. All right, so let's look at what these letters do. Your A has to do with like a vertical stretch or shrink, which we're going to call it the amplitude. Your amplitude, definition here, half the distance between the maximum and minimum values of the function. So it should always be a positive. You want the absolute value of that A to get your amplitude. So question, what is the A on 5A here? 1/2. Okay, so the A is in front of either my sine or A is in front of my cosine. And in this case, I had a 1/2 in front of my cosine, multiplied in front. So yes, my A is a 1/2, which means my amplitude, call it amp here, is a 1/2. I would have to take the absolute value of it, but the absolute value of 1/2 is still just 1/2. My amplitude is going to be 1/2. All right, so key points here. This is going to basically shrink. It's like a vertical shrink by 1/2. It's going to, instead of bouncing between 1 and -1, it's going to bounce between a 1/2 and -1/2. So let's see here. I'm going to go, are you guys okay if I go 1/2 and then I'll count up to a 1? Be like 1.5, 2, 2.5. I'm just counting by half. All right, so this would be my -1/2, you know, -1, that kind of thing. Usually I'm bouncing between +1 and -1, but this one, the amplitude changed to a 1/2, which means this is cosine, right? I'm going to go look at the cosine parent function. All right, here's my cosine parent function. I'm going to take a 1/2 of all the y values. So a 1/2 of 1 is a 1/2. All right, so it's going to hit that point. A half of 0 is still 0, so this point is going to stay the same. A half of this y value, a half of -1 is a -1/2. All right. Half of 0 is still 0. Half of 1 is a half. So it's going to be like a vertical shrink. Let's kind of squish this down, right? All right, so my key points. Let's see. I got the point, instead of 0, 1, I got the point 0, 1/2. And then over at the end of this cycle, I got a 2 pi 1/2. So I'm going to write my key points here. I have 2 pi 1/2. All right. All the stuff that hit at 0, I still hit at 0. So pi halves 0, still there. 3 pi halves 0, still there. Taking a half of 0 is still 0. All right. My minimum, I looked at, these are my maximums. I haven't looked at my minimum quite yet. The minimum was down in a -1/2. And let's see, that -1/2 happened right here with the x value of pi. So pi and then -1/2 instead of pi -1. Okay, so let's plot these points here. 0, 1/2. 2 pi 1/2. Maybe I'll count by pi halves again. Pi, 3 pi halves, 2 pi. Okay, so 2 pi and a positive 1/2. I got pi and a -1/2 right here. Pi halves hit 0, 3 pi halves hit 0. Again, it looks like a V, but I mean, I'm not going to graph this like a V. I got to make it a curve here. All right, so the amplitude, again, the amplitude is the distance between the maximum and minimum values. It's half of the distance between the maximum and minimum values. So my max was at 1/2. My min was at a -1/2. So that distance that's a distance of 1, right? So I want half of that distance for the amplitude. Half of 1 is a half. That's why my amplitude is 1/2. Okay. What kind of questions do we have on this stuff? Girls, we don't have any questions? Let's have you guys do this one then. It's still cosine, but they changed to amplitude to, let's see, the absolute value of 3 is 3. So they changed my amplitude to 3 now. Instead of bouncing between a half and a -1/2, I'm going to bounce between 3 and -3. Kind of off the chart here. There's my 3. Here's my -3. All right, so you guys take a sec, find your key points. Hit those key points, and we'll see what the final graph looks like. I'll give you a sec here. Find the key points if you have an amplitude of 3 now, like you did a vertical stretch by 3. All right, so for key points here, I'm gonna have Brett. Are you there, hon? Just wanna make sure you're there before I ask you. Awesome. Okay, so Brett, I'm gonna have you find the maximums, plural. You got 2 maximums, so you find those. Let's see, we're gonna have Kislev, are you there?
Yeah.
Awesome. So I'll have you find the x-intercepts, plural. There are 2 x-intercepts. Nicole, is Nicole there?
Yes.
Awesome, Nicole. I'll have you find the minimum. There's only 1 minimum in this cycle. All right, so we're gonna get the maxes, x-intercepts, and mins. You guys can just type them up whenever you get them. All right. So looks like my x-intercepts are at pi halves 0 and 3 pi halves 0. Looks like the minimum is at pi negative 3. And then we're gonna have 2 maxes. There we go at 0, 3, and so Brett and Nicole both have an x value of pi. I don't see an x value of 2 pi yet. So one of these is supposed to be a 2 pi, either my minimum or my maximum. One of those guys is at 2 pi. So maybe take a look at this 2 pi right here. Did that 2 pi hit a minimum or a maximum? Oh, Brett, so you got your maximum. Okay, so your maximum was at 2 pi 3. Okay. All right, so I'm gonna plot these points here. Pi halves 0 and 3 pi halves 0. Those are the same x-intercepts, which honestly, I think that kind of makes sense because you can multiply 0 by whatever, it's still gonna stay 0. Like they multiplied by 3 here, but still at 0. And then I've got, let's see, pi negative 3, my minimum, down to pi negative 3. Maximums, I got 2 of them at 0, 3, and at 2 pi 3. Okay, so this was like a vertical stretch. They like, stretched it out long and skinny here. It's still supposed to be a curve. Wow, there we go, it's a little better. All right, so there's our, that's 1 period for both of these, okay? Notice that this could go on and on and on and on. Same thing for the part A, the 1/2 cosine of x. This could go on and on, bouncing between a 1/2 and a negative 1/2. These are both cosine functions. The only thing they adjusted on these, they both are cosine of x, they just changed the amplitude. They adjusted what was multiplied in front of their function, which we were calling this an a in front of either the sine or the cosine. They adjusted the a, so it adjusted the amplitude. This is what it would look like. Any questions? No questions, for reals. All righty. Well, I think we only have a few minutes left, so I'm gonna call it for today.